Good morning, everybody. Today we continue our review for the final exam. Today's review will deal with Unit 5. So we are going to start off on page 13 where we're going to do our Unit 5 review for the final. Don't forget, Unit 5 is, of course, SOHCAHTOA, right? Basically, we're talking about trigonometry. So let me get my word wall ready as well for Unit number 5. All right, here we go. Find the reference angle of 160 degrees. Now, remember, here we're basically being tested on two things. Number one, I should be able to draw where 160 degrees is. So remember, when we draw our XY plane, we have our 0 degree, our 90, another 90 makes it 180, another 90 makes it 270, and finally, full circle, 490s would be 360 degrees. And so the next thing that we did when we were trying to find a reference angle, let's zoom in a little bit more here, is 160 degrees would be closer to the 180. And this is how we represented angles in standard form. This is my 160 degree mark. Now, when they talk about a reference angle, according to my word wall, it is the distance from the terminal angle that is closest to the x-axis. So if I need to head back to the x-axis, if I'm standing on the terminal, this right here would be what I call theta prime. Theta prime is my reference angle. So in order for me to find it, notice I am heading towards 180, even though my angle marker is 160. So to find my reference angle, which of course is always positive, then I'm going to take the 180 because it is the bigger number and subtract the 160. So my reference angle would be a nice little 20 degree angle. Again, reference angles should always be positive and they should always be less than 90 are the two things that you can tell yourself when it comes to reference angles. And so that's why we have the 20 here. Now, we're going to try it again. It says find the reference angle now of 320. All right, so we start off with a quick little draw of our XY plane. There's 0, 90, 180, 270, and 360. This is a skill you definitely need for math analysis. Now, we want to draw 320 degrees. So, of course, 320 degrees would fall in here in quadrant number 4. So I'm going to call that my 320 marker. But remember, you create angles. So you need to tell people that this circle or this angle was created with a counterclockwise spin, a positive direction spin. So there's my value. So I am going to use this number. I have to for my theta prime. But again, the word wall and the note that we talked about in class said, you go from the terminal side and you go the shortest distance back to the x-axis. That's my reference angle right there. So I'm going back to, or I'm going up in this case to 360. But again, reference angle should be positive. So when I do try to find my reference angle, I will take the bigger number of the two and subtract the 320. Remember, my answer should be positive and less than 90. And yes, of course, it is both of those things. So there is my reference angle for this problem. All right, so again, reference angle should be positive and less than 90. Moving right along. Converting. So we have two types of conversions that we did in class, and either both are going to be on your test or maybe just one of them. We're not sure which one, so we're going to practice both. We're going to convert 250 degrees to radians. Again, if you forgot how to do a conversion, your word wall does remind you about it. Right now, we're going to turn, this is in degrees. So you see, I'm going degrees to radians. I'm going to multiply my angle times pi over 180 because I do want the degrees to cancel out. So I do have a 250 right now that I am converting, 250 degrees. I'm going to put a 100. It just helps to remind me that I'm working with the numerator and the denominator. And then I want radians, so pi is on the top. The equivalent to pi is 180 in the degree world. But I know it's very small, you don't really see it, but we're basically canceling out the degree symbol. And then, of course, we make our elementary teachers proud. We multiply straight across, 250 pi divided by 180. But of course, you should be reducing your fractions. You can use decimals. You can reduce in your own way. For instance, if they both end in 0, then I could take out both zeros. But even with the reduction on decimals, we do get a 25 pi over 18 because they can both be divided by 10. And then these numbers can no longer be reduced. So there's our 250 degrees written as a radian. We recognize radians with the use of pi. Now, vice versa, they want me to convert 13 over 12 pi to degrees. Well, first of all, that pi, let's take care of that. See, the first thing I'm going to do is I'm going to write it as 13 pi over 12. So we do a little bit of a rewrite. The pi does belong in the numerator with the 13, not with the 12. But according to the word wall, I'm going to multiply this. Well, remember, this time I'm going into degrees. So 180 on top or 180 at the bottom, well, it should be on the top. You want to end up with degrees. So your pi should be underneath. And it makes sense that the pi's at the bottom because look what happens when you multiply. Your pi's are officially gone. We can just cancel them out. So we're gonna multiply straight across. So 13 times 180. Well, let's see. 13 times 180. Okay. Got 2,340. But no more pi's. Don't forget, I'm just going to divide that by 12. So divide that by 12. And I get an answer of 195. So there it is in degrees. The equivalent of 195 degrees, 13 over 12 pi. Now, the next thing, evaluating. This is going to be one of the bigger things that you're going to need for math analysis and for calculus if you were to go there. They want me to evaluate what cosine of 7 pi over 4 is. Now, pi over 4 is one of our reference angles. And so there's a couple ways of doing this. One of the techniques that was taught to the CP course was this. This is a unit circle question. And when you have a unit circle question, first thing I do is I locate 7 pi over 4. So as I'm looking, here it is, 7 pi over 4, which means I'm going to use this point here. Radical 2 over 2, negative radical 2 over 2. So that's the point I use for that angle. I'm going to use the point radical 2 over 2 and negative radical 2 over 2. Now, one of the reasons we're using this for our test, yes, you'll be able to use a word wall. According to our word wall, this is the answer for cosine instantly. This is the answer for sine, once again, instantly. So since they're asking for cosine, look how simple it is. Once you locate the point, you just have to pick carefully. This is the answer for the cosine there. So my answer is radical 2 over 2. And just like that, we're done with this problem. Yes, you could use right triangles. There's different ways of doing these problems. But if we're allowed to use the unit circle, we just have to know which one of the 2 points or values we're going to use. Let's try that again. See, now this one says cosecant. Now this one's a little bit different, but I'm not going to change my technique. I am going to look for this angle in my unit circle. So I go to my unit circle. I'm looking for 5 pi over 6. Let's see. Let's try to find it. 5 pi over 6. All right, so here it is. 5 pi over 6. So I'm going to use the point negative radical 3 over 2 and 1/2. So negative radical 3 over 2 and 1/2. Now, what are they asking me for? Now, don't forget, this is the answer for cosine. This is the answer for sine here. But they're asking me for cosecant. Well, we have to remember a couple things about cosecant. We have to know who's related to cosecant. And so as I look at my word wall, here's your reminder. Remember, it has to do with SOHCAHTOA here. Cosecant, here we go. Cosecant is related to sine. So whatever sine is, all I have to do is flip it over. Well, I know what the answer for sine is. The answer for sine is 1 over 2. Well, then the word wall is telling me to flip, not this, but the answer for sine is 1 over 2. So I flip it over, and it's just 2 over 1 because it said cosecant. So I'm just going to write 2 because 2 over 1 is something I would never write. But again, these are very straightforward. problems where I use the unit circle, and we have to recognize that when they ask for this, it's a unit circle question. Now, this one right here, yes, it's going to be on our test for the CP test. Find the angle that satisfies both equations. So now I'm going to reverse this thinking. See, what I did in the previous problem was I looked at my angle and then I wrote down my point. Once I wrote down my point, I used these numbers, these values, to find the answer to this entire trig question. Well, here it's a little bit different, but that's why I look at your word wall. It's cosine first and then sine. So this is the x, this is your y. Well, let's write it down. It is the point radical 2 over 2, because that's the x, negative radical 2 over 2, that's my y value. So all I have to do now is I'm going to look for the angle, I'm going to call it theta, on my word wall that matches these two numbers, radical 2 over 2 and negative radical 2 over 2. So here we go. I'm going to get that unit circle going. Now notice I am looking for a positive x and a negative y. So if I'm looking at the entire circle, well, think about it. Positive x, I would go this way. Negative y, I would go down. And yeah, there it is. Look at that. A perfect match right here to that point. So then the only angle that I'm using is if theta is 315 degrees. Or maybe they're going to ask me to give the answer in radians. Well, there it is, 7 pi over 4. It just depends if they want, if your multiple choice questions are radians or degrees, one of these two would be the answer. But again, it's the unit circle that helps you get to these answers very quickly. Now, yes, you have the u-dos on that side, but flip it over. We really only have one more page to go. So let's flip this thing over so we can do a little more practice here. Yeah, that's it. Just one last page. Now, here it is. The big thing that we do in this class was trigonometry, and of course, bringing in our friend SOHCAHTOA. So it says, use ABC below to answer the following questions. Find x, round it to the nearest tenth. Now, it does say the nearest tenth, right? The number 10. So then that means just one number after the decimal. For those who still struggle with trying to remember, well, how many numbers do you need? Well, there you go. Remember, that's the trick. 10, you write the number 10. It has 1 0, so one number, just one after the decimal. All right, but we already know. If we see a right triangle, yes, sometimes we think about Pythagorean theorem, but I don't know this side. But as soon as we see an angle show up, like they did here with the 55, this is how we know that our friend SOHCAHTOA is going to help us out. Now, we need to label. When we label for SOHCAHTOA, we always do opposite adjacent hypotenuse. This is my angle. That makes this side the opposite because there's no contact with that angle. This is the hypotenuse because it's always across from the 90. Look at how the 90 points to it. And of course, that makes this the adjacent. So when I'm looking at this problem, yeah, there's a value that I'm looking for. That's the only number they gave me. So I don't need anything with an O in it. So if it has an O, I'm going to cross it out. This has an O. That has an O. There you go. There's the trig function we're going to go with. C, of course, stands for cosine. So I'm just going to throw this out here a little bit. Cosine of, well, remember, trig needs angles to survive. The only angle that we're using is 55. So 55 is equal to a fraction. Keep looking at the name. C is for cosine. A, well, it says 15. H is the x. So now, as usual, we are going to cross multiply. That is one of the techniques, one of the ways that we can solve this. So a little cross multiplication, and we get 15 times 1 is 15, is equal to x times cosine 55 is exactly what we said, x cosine 55. Never put the x in the back, leave it in the front, because now I know x is not by itself. Well, then there's only one way to get rid of cosine 55, and that's to divide by cosine of 55. So cosine of 55 is gone. The x is by itself, so this is where we bring in our calculator to help us out. So just remember, you do need to be in degrees. This is not in radians, so make sure your calculator is in degrees. And when you type it into the calculator, we get the answer of 26.2. Rounded again to one decimal place, they said. So 26.2. All right, so we are definitely going to have SOHCAHTOA on the test, as usual, as expected. Now, next one. Number 16, here's the word problem that we're going to have on the test when it comes to trigonometry. A ladder is leaning against a tree. If the angle that the ladder makes with the ground is 53 degrees and the ladder is 15 feet long, how far up the tree is the ladder? Round to the nearest whole foot. Now remember what that means. If you're rounding to the nearest whole foot, that means no decimal. No decimal at all. Give me a nice whole number. Whole numbers only. All right, well, let's figure this thing out. Ladder's leaning against a tree. Okay, so I'm sure it's safe to assume we're on the flat ground here. There we go. We're on the flat ground. Here is the tree, of course. Look at that fancy tree there. We're not all trees make a 90-degree angle, but obviously because of the topic we're on, we're gonna make sure that's a 90. But then here comes the ladder. The ladder is leaning against a tree. Leaning doesn't mean right up like this. Leaning would be this. There's my ladder, okay? And if you're wondering, why'd you put all that space? It doesn't matter, it's just the ground anyways. Okay, so we're gonna read the problem again, and we're gonna put information where it belongs. So it says, a ladder is leaning against a tree. If the angle the ladder makes with the ground is 53 degrees. Well, we know it can't be that one, that's 90. So there it is. This is the one that has to be a 53. They said it's on the ground. And the ladder is 15 feet long. Well, again, the ladder is not the ground. This is the ladder right here. So there's my 15 feet. How far up the tree? That's the question. That's where I'm going to put my X. How far up the tree? Well, you got to go up the tree. This is where they want you to put the X. And just like that, we're ready. We've used every piece of information they gave me. We put an X on what they want us to solve for. So this is my opposite. This is my hypotenuse. And yeah, this is the adjacent, but there's no information there. So we don't really need that. So again, when I'm thinking about my friend SOHCAHTOA, it's just O and H. So look, as soon as I start to write it, there it is, OH. We don't want anything that has an A in it. So these would be gone. And that would be the winning trig function that I use for this problem. So we're going to go with sine. S is for sine, but again, I need an angle. That's why we have our 53 is equal to a fraction. And then look at the name, O and then H. O and then H. All right, let's put a 1 under it. We know we are going to cross multiply, so X times 1 is just X. And look at that, the X is already by itself. That means I'm going to be ready for a calculator right away. 15 times sine of 53 is exactly the way we said it. The trig function always goes in the back. Again, the reminder, you should be in degree mode when using Desmos. So we're ready for the calculator. Don't forget, we're going to say no decimal. So once we type it into Desmos very carefully and you round it, we should get a result of about 12 feet. That's how high up I can go on that tree if that's the angle I use for the ladder in the ground. So that takes care of the CP portion of the final. But just in case, for those in the honors class, we will show you these last two questions here. Now, only for the honors class. If sine of theta is equal to 12 over 3, find the following trig functions: cosine, tangent, cosecant. Now, oh, this is kind of nice. Look at this. They already said sine is 12 over 3. Earlier, we saw that cosecant is just the flip of sine. So if I already have the answer for sine, then I automatically have the answer for cosecant. If this one's 12 over 3, then look, 13 over 12. Just like that, I already have one of my answers without much work. Now, the others I'm kind of stuck. So one of the best things we can do is, well, we have to know how to spell the word SOHCAHTOA. It's S for sign, O, H, which means I'm going to draw myself a right triangle. I need to pick an angle and call it theta, not this one. That's the 90. So look, I'll just call this theta. There's my angle. And if that's my angle, here's the opposite adjacent hypotenuse. And now look, we have our numbers. Opposite is 12. The hypotenuse is 13. Man, I only need this number. Just remember, if I have two sides of a triangle, Pythagorean theorem is what will give me that last value. But before you bring in the Pythagorean theorem, a squared plus b squared equals c squared, the one thing that you should look for right away is for that Pythagorean triple. See, there's my hypotenuse of 3. There's my opposite of 12, which means, looking at the Pythagorean triple, this would just be 5. So, with that said, now I can do everything else according to SOHCAHTOA. CAH. Well, there's the C. So all I need is the A, 5, and the H, 13. And just like that, I'm done with that problem. And then for the other one, tangent, well, that's the TOA portion. Well, we already have the T, meaning the O is first, so 12. The A is the 5. There's our answer. All right. One more to go here. One more to go. So to finish it off, for the honors portion of the test, we weren't going to get away from it. We do have a trig identity problem. And so remember, we want to simplify and we have to take it as far as we can. Now on the test, it'll be multiple choice, so you'll have an idea of when to end it. But one of the things we want to do here is, you see, I see a cotangent squared and a cotangent squared. They both have it. Excuse me. So I'm going to factor. And remember, the very first step in factoring is called the GCF. Well, they both say cotangent squared. Then let me factor that out. So cotangent squared of x, I'm factoring it out. But don't forget, there is a minus sign. You can't just ignore that. There is a minus sign. So I do need something in front. So if I took out the cotangent squared, then you have to at least put the number 1 here. Remember, you should be able to multiply it. This times this is this, minus, well, here I took out the cotangent squared, leaving me with cosine squared x. All right, so there's our first step. Little GCF helped. Now, I do see a lot of powers of 2. When I see powers of 2, this is where we now bring in our identities. So here it is. Remember, honors, you had a whole special thing for Pythagorean identities. And as soon as I saw 1 minus cosine squared, that triggered this idea. Look at what 1 minus cosine squared represents. 1 minus cosine squared can be replaced with sine squared. I know it says theta here. I'll just write x for this one. So according to our word wall, cotangent squared x, there we go, sorry. All of this just becomes sine squared x. Now, okay, so I mess with this one. So now let me look at what cotangent squared equals. Now I could call it cosecant squared minus 1. That doesn't seem too good for us, but I can call it this. Cotangent is the same as cosine over sine. So here's cotangent, and according to the word wall, that's the same as cosine over sine. But remember, this one does have a power of 2. Then you need to continue to write that power of 2. Now, this side was done. I don't want to mess with it. It was just sine squared x. And now that you look a little closer, notice, if I were to put a 1 under it, you should be able to see that you have a sine squared at the bottom of a fraction. They're multiplying, which allows canceling to occur. And then there's a sine squared here. Look at that, they're gone. And the only thing left, because the 1 doesn't do anything for me, is cosine squared x. When you are simplifying, you are doing your best to try to reduce this expression into one trig function, a number. You're trying to reduce the look of it. And that's what simplifying is. It's us manipulating a problem using our trig identity. So make sure this page is ready for the final exam. All right, everybody, with that said, we are done with the Unit 5 review. Have a wonderful day, and I'll see you next time.